All right. So what we're going to do today is we're going to talk about the derivatives of natural logs, and let's get after it. All right. So here we have the derivative in terms of x of the natural log of x, and this is going to equal a simple, very simple rule. So the derivative of the natural log of x is 1 over x. As we know from past lessons and past experiences, this is not always going to be an x. So what happens when that is the case? We have u substitution. So we must be thinking in terms of the natural log of u, which is simply, remember, just simply something other than x. So good news is that has a nice easy rule. It is u prime over u. You also might see this at times as simply 1 over u times u prime, but you'd multiply the u prime back in, so might as well just handle it in this form. So let's get after a few examples and see how this works. All right, so we have the derivative in terms of x, the natural log of 5x. Let us not forget, this is not x, so we need to be thinking about u substitution. So we're going to call that junk inside u. Let's go over here, and again, if you've watched my videos, you know that I'm going to end up taking derivatives over here. Just kind of a place I put my notes. Let's find the rule. The rule at least reminds us we have a u we can use, but we need a u prime, so let's go get that. Derivative of u is u prime, derivative of 5x is 5. And again, this is really clean. We can just take the u prime and put it where it goes and put the u where it goes. And the only thing left to do here is cancel these 5's and write it as 1 over x. The natural log of 5x equals 1 over x. All right, let's do another one. All right, so start off thinking about, well, again, it's not x. So what would you call u? Hopefully you just pointed right there. We have u equaling 7x to the fourth. Again, let's write the rule. I like to do this over and over again. You write the rule enough times, it's just something that is branded in your brain. Again, reminds we have 2 pieces of information we need. We currently have one. Let's go get the other one. Derivative of u was u prime. Derivative of 7x to the fourth is 28x to the third. Again, there's our 2 pieces of information. Let's toss it in. And from here, we're just, it's no longer calculus. This is just pretty much an algebra 2 problem, or maybe even an advanced algebra 1 problem. We have 28/7. That's going to reduce to 4. There's going to be a 4 left on top. 3 of these x's are going to cancel with 3 of those, leaving me with an x on the bottom. This should be 4 over x. And that is the answer. All right, let's do another one. Starting to mix things up, we now have a negative exponent. We've known in the past, negative exponents kind of create some simplification issues. Let's see what happens with this one. Again, think about what are you going to call u? Write it over here. Let's create the rule and find the piece that's missing, that u prime. And again, this is going to be u prime. This is going to end up giving me negative 6x to the negative 4. Remember, we are subtracting 1. And let's throw it in. Now, from here, there's several different directions, and could either be how you taught it or how you learned it. How you learned it, or how you're thinking about this problem. But there's several ways to simplify this. I mean, we have negative 6 over 2. Well, that's a negative 3. I already know there's going to be a negative 3 on top. And then you could be saying, well, in a division problem, when the bases are the same, you're supposed to subtract the exponents. So this is ultimately going to give me negative 3 x to the negative 1. That might be complicated for you, so I'm just going to branch this thing out. Let's expand this. Let's put this in without negative exponents. So what was this? This is just negative 6 over x to the fourth. This was just 2 over x to the third. We do have a fraction being divided by a fraction, so I'm just going to put it over here. Let's remind ourselves that when we divide fractions, we're supposed to convert this to multiplication, and we're supposed to flip this fraction. So let's do that. And now at least we have a visual representation that this is going to become a -3. And that this, through cross cancellation, right? We're cross canceling here, we're cross canceling here. And I'm going to be left with -3 over x. And all of this work is not necessary if you knew some of those rules. But either way, the right answer is the right answer. Okay, so let's do another one. Let's just continue to complicate this a little bit so we can show different levels of work. Okay, we have the derivative in terms of x of 11 times the natural log of -4x to the fifth. Now, ultimately, what we have right now is we are taking the derivative of a multiplication problem. If we don't do something right here, the derivative over here should equal the product rule. And the last thing I want to do to this is the product rule. Because remember, we had that rule that was called constant multiple. I can take this 11 and I can bring it out. So let's do that. That 11 can be brought out. It's important that if it was 11x, it could not be brought out, but just because it's a constant, we can bring it out. So I'm just dealing right now with 11 times the derivative of this. Well, this is where we were in the last few examples. So let's call this u. So there's my u. Now remember, we have a rule here, but I just want to remind you that I'm now taking 11 times that rule. Still only having one piece of information that's missing, so let's go get it. Derivative of -4x to the fifth is -20x to the fourth. Now let's take our information and drop it in, keeping that 11 times, carrying it through. And now we can simplify this. -20 over -4 is 5. 4 of these x's will cancel with 4 of those. Should leave me with 11 times 5 over x, which is 55 over x. So there's the answer to this problem. And I was able to kind of clean things up by just saying, hey, I've got an 11 in front. I can move that out. Okay? So in this case, we don't have a number in front, but we do have something raised to an exponent. So this is a different situation. Now, we could call this entire thing right here, including the fourth power. We could call all of this u. We could jump over and write that over there. But remember, whatever we write as u equals, we must take its derivative. So if I took the whole thing and brought it over here, its derivative would require a chain rule, which is not necessarily wrong. Matter of fact, it's not wrong at all. And you could do it that way. Excuse me. I'm not going to do it that way because I just want to remind you that there is a natural log property that I can use. And the property says if I have a natural log that is raised to an exponent, I can take the exponent and I can put it out front. So I can move the 4 in front of the natural log. That was a natural log property that you learned back in Algebra 2 and Pre-Calculus. And because of the last example, we just reminded ourselves that, hey, because I have a number times, I can move the number out front. So I'm going to do that there. Now we're exactly where we were a few seconds ago with the last example. I can call this u. I know I'm going to take the derivative. It's a really easy derivative. I'm going to have a rule here, u prime over u, but I'm going to remind myself it's 4 times that. Let's get our derivative, which is 7. Let's throw our information in. These 7s will cancel, and I'll be left with 4 over x. And that is the derivative of the natural log of 7x to the 4th. Okay? Again, you could have grabbed this whole thing and could have gone over here. Matter of fact, you may even want to try that and just match your answers. It just becomes a little bit more complicated here and less complicated there. All right. Now, I didn't want to lull you to sleep thinking that everything's going to be, a monomial or just one term. So we can have a bunch of junk in here. It makes no difference. I'm going to call all of this u, because that is not a difficult derivative. Matter of fact, calling that u makes our life a lot easier, because now I just got the natural log of u. So I've got a rule. Let's get our derivative, u equaling 10x plus 2. Two pieces of information to throw in, so let's do that. And I get these questions a lot about, well, how do you know when you're done? And I think the question is pretty much referring to the simplification process. And this is what I tell my students. When you're dealing with simplifying, I'm going to point out that I could actually factor out a 2 here. I'll just show that right there. But the only time I would do that, really, is if, let's say, I could also do something where there was a factor of 2 down here, where they would cancel. But because nothing in here was going to cancel with anything in here, I honestly could have just left this as an answer. Certainly could have answered it this way, but either one of those would have been acceptable. Okay, let's do, I think, one more. And of course, we want to end with how I always end these. This is a chain rule issue. Let's do a problem that has a chain rule inside a chain rule. Now, we cannot just jump right here and call this u. Because if you did that, we would have the natural log of the sine of u. Well, we don't have a rule for that. The only thing we have a rule for is the natural log of u. So we better call this entire thing u. Now again, when I call my u equals, I already know whatever I'm doing here, I'm thinking I will need its derivative. So I'm always cautious after I write it to ask myself, am I creating an issue with the derivative? Of course, I'm not here because I didn't have any choice. But this is a chain rule derivative. So let's write the rule. I need my u prime. But don't forget that in order to take this derivative, I have to be taking the derivative of the sine of u, because remember, there's a rule for that. And the derivative for the sine of u was cosine u prime. So derivative of u is u prime. The derivative of the sine of 3x should be 3 cosine of 3x. Now I have my two pieces of information. I can throw that here. Now I can throw that here. And that would not be the answer. Not in a calculus class. And the reason it's not the answer in a calculus class is because you have gone through pre-calculus. And the expectation is you learned identities. So let's not forget that this was an identity. You would have learned it as a quotient identity. And the cosine of x, and I understand this is not an x, but I'm just going to remind you. So the cosine of x over the sine of x was cotangent. And since these both have a 3x, I can say that the cosine of 3x over the sine of 3x is the cotangent of 3x, and that 3 comes for the right. So that was a quotient identity. That would have been the most acceptable answer in this problem. All right, so basically just, pretty simple rule. Ask yourself, what are you going to call u? Jump over, do that. Understand you will always be taking its derivative because you need both pieces of information. Just generate a place for your notes and then toss the information in, and then the rest of it just becomes something other than calculus. All right, well done.